Let's build a machine learning model together. Today, we'll be building a logistic regression model to predict whether an incoming email is spam, and this is one of the most iconic baseline models in machine learning, so let's break it down together. First, I need a dataset, so I'm searching around Kaggle, and I decided on this one called email spam classification. Before I build anything, I always take a minute to understand what I'm actually looking at, because the way the data is structured tells you what kind of model makes sense. When I open it up, the first thing I notice is that this isn't raw email text. It's already been converted into features. Every column is basically a word, and the values are how often that word shows up in that email. There's also an ID column, which specifies the index of the email, and a prediction column that is the target label. This is the spam or not spam label the model is trying to predict. So right away, that changes my plan. Since the text is already turned into word count features, I don't need to do any fancy NLP pre-processing. My job is to make sure the model learns a clean relationship between the word patterns and the label. Then I do a quick quality scan. Any missing values? Anything that looks like a weird column that shouldn't be used? The big one here is the ID column. Because it's basically just an index, it has no relationship to spam, but models can accidentally exploit patterns if I leave it in. So I'm flagging it for now because that information will come in handy very shortly. Now that we've met our data, let's actually get coding. As always, we start by importing all the necessary libraries. For this model, we need NumPy for math, pandas for data, and a bunch of tools from scikit-learn to split the data, train the model, run predictions, and evaluate it. Then I load the data into the data frame and make sure everything looks as expected. Now it's time to define my target and features. The target is, of course, the prediction column, which is the spam or not spam label, and the features are all the word columns. Going back to what we learned about the data, I'm dropping the ID column before I do anything else because I want the model to learn language patterns, not row numbers. Now I split the data into two sections, training data and testing data. We're allocating 80% of the data for our training set. This is what the model learns from and is allowed to find patterns in during training. Then the other 20% goes to the test set, which is meant to simulate future data so we can test the model's performance on unseen emails. Here I'm choosing to stratify the split, and this just means I'm forcing the train set and the test set to keep roughly the same class ratio as the full data set. So if the overall data set is, say, 70% not spam and 30% spam, then the train set will also be around 70-30, and likewise for the test set. That way, the test set is a fair reality check. If I don't stratify and the class balance shifts by accident, my evaluation can start lying to me because the test set wouldn't represent the same world the model is trained in. Now I'm at the model choice, and this is where I'm really listening to the dataset. We have a giant table of features with thousands of columns that are mostly zero. I want a model that's built for a high-dimensional, sparse dataset but can still give me a clean probability at the end. That's why I'm going with logistic regression. It's not fancy, but it's a perfect match here. If you're new to logistic regression, here's what's actually happening under the hood. The model starts with a weight for every feature, basically how important each word is. If a word is strongly associated with spam, it gets a positive weight, and seeing that word pushes the spam score upward. If a word is associated with normal emails, it gets a negative weight and it pushes the score downward. All of those weighted signals get added into one final score. Then the sigmoid function turns that score into a probability between 0 and 1. And once you have a probability, you can set a threshold. A common default is 0.5. Anything above that is spam, and anything below that is not spam. But in real life, you could choose a threshold based on what you care about. A higher threshold means you flag fewer emails but with fewer false alarms. Lower threshold means you catch more spam, but you might accidentally flag more real emails. So now let's build one of our own. But before I start training, I'm adding one tiny simple scaling step, and here's why. These word count features are mostly zeros because any single email only uses a tiny fraction of all the possible words in the dataset. So if there are thousands of word columns, most of them will be not present for a given email, which shows up as 0. But as we all know, some words are just more common, and when a common word appears a lot of times, its count will be much bigger than other features. If I do nothing, a handful of these common words can dominate the learning process just because their numbers are larger, not because they're more meaningful. So this scaling is just me standardizing the units so the model can learn weights more fairly. Now we are finally training the model. Logistic regression trains fast, but I'm still watching the model's behavior as it updates. During training, the model is always adjusting the word weights so the scores of spam emails go up and vice versa. I'm watching the predicted probabilities because that shows us whether it's separating confidently or hovering around, I don't know, near 0.5. And after training, I can find finally evaluate on the test set, and this is the moment that matters. I'm not impressed by training performance because the model has already seen that data and knows it very well. What I want is performance on unseen emails because that's the closest thing I have to real life, and that's where my testing data comes in. So here's what evaluation actually looks like. I take the inputs from the test set, the word count columns for the emails the model has never seen, and run them through the trained model to get predicted probabilities and predicted labels. Then I compare those predictions to the true labels and calculate metrics that tell me how the model behaves. And today I'm evaluating with PRAUC and precision and recall because those will tell me the most useful information about the model. My PRAUC is around 0.96, which means across many possible thresholds, the model is ranking spam above not spam really well. Then for the actual spam class, the recall is around 0.98, which tells us that out of 300 spam emails in the test set, the model correctly caught 295 and missed 5. The precision for spam is around 0.88, which means when the model flags something as spam, it's right about 88% of the time. And the confusion matrix just reiterates all of these findings. Now we can finally use the model and test it like we would in real life, so I'm pasting in a real email. It says, "You've won a free gift card. Click the link to claim your reward today." This is pretty spammy, so let's see what the model says. And lo and behold, the model predicts this email is spam with almost 70% certainty. So that's all for today, but don't forget to save this video for your next machine learning adventure and follow for more. See you in the next one.